We're doing notes again. It's been so long. Stats. The good news is that my interpretation of IB has been, it is my first year, you're basically having to take every class again, and it just includes all of the hard stuff from every class, basically, and you're trying to go really fast. So we did functions, and it was honestly Algebra 2 and math analysis, and there was different kinds of terminology, different looking questions, but for the most part, stuff that was very things we've heard before or near things we've heard before, which normally means at the start of a unit, it's pretty easy. It's pretty simple. And so today, we've already spent some time talking about the test. It's gonna be pretty simple. It's gonna be pretty easy. In fact, most of what you're doing should feel like, okay, this feels good. I feel really, this seems pretty easy. Of course, we're gonna introduce the IB way of asking questions, and you'll probably have a thought of, how do they make this hard? It's supposed to be easy. But actually, after a deep breath, you'll be all right. So, yap aside, we're gonna start with measures of central tendency. Have we ever heard of measures of central tendency before? Yes. And maybe you don't remember quite what that is, but there are 3 of them, and they all start with M. You learn stats in 4th grade, and you learn the measures of central tendency. There we go. We've got mean, median, and mode. If I give you a quiz right now on mean, median, and mode,
would I pass? No.
You're not feeling too confident. All right, well, the good news is, mathematically, very simple concepts. It's more vocab than it is math. So your mean is your average. And again, we're talking stats, so we're talking the average of the data. So we're talking, you're gonna get a whole bunch of numbers. 2, 8, 6, 13, 12, 11, 10, 9, 3, 3, 3. And your average of all those numbers is called the mean. Then we've got the median. What's the median? You're already passing. You're doing so good. Yep, the median is the middle. And lastly, we have the mode, which is the most. The number you have most, which pretty much, you're right on it, is the number that has the most repeats. It is not all the numbers with repeats. It is the number with the most repeats. And measures of central tendency, the mean, the median, and the mode. Now, to go into them a little bit more, to make sure that we have all the different kind of definitions and maybe some formulas. For the mean, we are going to be using 2 letters for the mean, and those 2 letters are that and that, or I should say that or that. Have we ever seen either of those before? Now, it's not really an M, but it does look basically just like an M. I want you to think of this more like a U that has like a J on the front of it.
Okay, J-U. What is it called?
It is called a moo, like a cow.
Yeah.
And when I was in high school, I was in a math club that was called Mu Alpha Theta.
Mu Alpha?
Mu Alpha.
Which was a math honor society. But anyways, you don't want to write it on your paper like an M. You want to write it on your paper like a U that has this extra leg. Again, it kind of is an M, but the way that leg works, I think as soon as students think of it like a U, it just kind of connects the dots for them a little bit better. What about this X thing?
Never seen it in my life.
So this can be called X bar, meaning the bar on the top of it. X bar, which sounds a little familiar. And technically these can be a little different. Honestly, I don't think that you really need to know the difference of the two. Mu is a little bit more usable when we're talking about the whole population, meaning the entire United States or the entire set of data, whereas X bar is more talking about like a sample size, you know, like a smaller piece, which again, more or less when you do a question, you don't have to worry about the difference. If it says mu, it means average. If it says X bar, it means average. And it's kind of like Mew, like the Pokemon Mew, more than it is moo, like the cow says moo. But nobody's really gonna be zinging you too bad if you say it wrong. Hopefully, that's right. Now, the median is just gonna be called the median for the most part. I'm not sure that we have any kind of really crazy, but we'll talk a little bit later. A sneaky way that they could refer to the median is by calling it Q2. Again, that's not really like you wouldn't want to write Q2 equals as a shorthand for the median, even though it would make sense. If that, like Q2 is the median, but it's not a great shortcut for median. And then when it comes to mode, the mode is just the mode, right? The mode is the easiest, the dumbest one, right? Which one do you see most? Cool, it's the mode. You don't need a shortcut for the mode. You don't need a formula for the mode. You just look at it and you just pick the mode. So the mode is like, you know, one of the Three Stooges, I guess, which makes them all Stooges, which is a terrible reference. Okay. Now let's talk about actual, a little bit more formula style. So let's start with mean, which is, what are the two?
What do we say?
Mu and X bar.
U and X bar, or again, I should probably say mu or X bar, but that's just for the sake of you remembering and repetition. Welcome back. We're doing notes and we'll catch up really quick. Now, the mean is x1 plus x2 plus x3 plus xn. And so we need to kind of adjust from the very high school way of thinking about it more towards the college way of thinking about it, which is a formula that looks pretty much like this. All of those little x's would be all of the different terms. So this x1 is like the first data point, and x2 is like the second data point. You guys get it? Dot, 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 xn. What do you think xn is? It's the last data point. And they don't really have order, but if you have 10 things, then x10 would be the final one. And how do you complete this formula? You add them all up and you divide by n. However many you have. If you've got 3 things, you add them all up and you divide by 3. If you've got 10 things, you add them all up and you divide by 10. Again, there's, you know, if you want to think about this still as a simpler kind of high school methodology, you could just say add them all up and divide that by how many? Right? I mean, that's the same thing. It just looks a little bit less complicated, a little bit less scary. Now, I was doing a little bit of research here. Again, I have a lot of work to do tomorrow on the day off, or on the teacher work day to make sure. But when it comes to adding them all up, we could use Luke's favorite, sigma notation. Have we ever heard of sigma notation or seen sigma notation with the big choppy E thing? So this is gonna show up. I'm not sure how soon it's gonna show up. It could technically show up in mean because you do a little bit of adding them all up. So they could say something like sum up all of the terms and maybe they would use xi. I mean, I don't know. I don't think that doesn't seem like it makes it simpler or smarter, but maybe you possibly could see sigma. And again, sigma is just talking about the sum. Do you have anything to add to that, Luke? Is there anything that sigma means to you beyond that? I got you. I went home on Thursday and I just told my family right away about how moving that was when you gave your presentation. I'm so deep. Okay, now let's get to median. Now median is where things are still pretty easy, but maybe they're not as just like the first thought in your head easy, okay? How do you find the median? What do you say? The median is the middle term.
Numbers like in increasing order.
You could put the numbers in increasing order, and then what would you do as the final step? Cross them off. Is that what you're talking about? Cross them off kind of one at a time? I mean, that would be a way that you could do it if you were trying to do it by hand with a whiteboard. But mathematically, formula-wise, what could the formula be?
Wasn't it like
What do you say?
middle point formula?
The middle point formula. That's almost making it too complicated. So, let's say we have 100 terms. Maybe that's too complicated. Let's say we have 10 terms. What is the middle term? Maybe that's too complicated. Let's say we've got 9 terms. Well, that's too complicated. Let's say we've got 3. If you've got 3 terms, A, B, C, which term is the median? B. Nice. It's just the middle one. Okay? So now, let's say you've got 5 terms. Which one is the median? C. Now, if we're talking about having 5 terms and the median is C, how can we find a little formula to help us figure that out? What if we had 99 terms? What would be the middle term if they were all in order? We need to use the number 99, right? Divide by 2. Now let's go back. A, B, C, D, E, 5 terms, divide by 2. That doesn't really work, right? 5 divided by 2 is not the third term. It's 2.5, which would be here, which is not in the middle. So how can we fix our formula? It's really easy to do. How can we fix our formula? What do you say? Oh, +1. +1. Now it says 6 divided by 2, which is 3. Now the formula is fixed. So again, it's an easy little formula, but it's just not the first thing that pops into your head. You think, oh, I got it, it's n divided by 2. And actually it's not. It's n plus 1 divided by 2. So what is the middle term if you have 99 terms? Term number 50, right? And you can, now it's super easy, you can do it in your head. What is the middle term if you have 201 terms? Add 1, who cares? 202, cut it in half, 101, who cares? It's 101. You can do it in your head, even if it's a big number. And we're not going to be doing things with 200 terms. Now, we talked about all of this. Okay, cool. We have a nice formula for the median. If we get rid of 99, we can just use n as a placeholder number. How many terms do you have? N plus 1 divided by 2. We've talked about 3, 5, 9, 99, 201. What have we not talked about? Even numbers. But you've learned median before, and it's no different. What do you do if you have an even number of terms? Let's say you have A, B, C, D, E, F. Well, there's no middle term in there. So what is it? Do you say no median? Do you say that C and D are both medians? What do you say? So what you would do is you would say whatever is the middle of those two becomes your median. So let's replace this with numbers. Makes maybe a little bit more sense. Let's say we had 1, 2, 3, 4, 5, 6. What would the median be? It would be 3.5. Right? Just between 3 and 4 is 3.5. Does that work? Okay?
The formula would work the same way with even.
So the formula would be 6 terms plus 1 is 7. 7 divided by 2 is 3.5. Now, I need to elaborate a little bit because this tells you what term is the median term. The only reason that 3.5 worked that way, Lexi, is because I chose the numbers 1, 2, 3, 4, 5, 6. The true answer, let's do this again. I'm gonna pick the numbers 2, 4. Let's pick bigger integer or whole numbers as we keep going. What's another one? 12, bigger than 12.
16.
16. Let's stop there. Now, we could say, what term is the median? There's 4 terms, plus 1 makes 5, divided by 2. It tells me 2.5. That tells me that term 2.5 is the median, which means it's the term in between 2 and 3. Now, what do we do to figure this out? What number is between 4 and 12? Sometimes you can do it in your head and just think 8. Right, this is one that's pretty easy to do in your head. Or, if you're not so sure, you can just do 4 plus 12 divided by 2. Right, just figure out the little baby average of those two numbers. So, if we have an odd number of terms or items or data that we're talking about, it's pretty easy. You just pick the one that's right in the middle. If we have an even number, it's still pretty easy. You just look for the middle number between those two middle terms. Okay, now so far, even though it's been a little bit different, we certainly are a long way away from talking about even and odd functions. It still probably doesn't seem very hard, so how are they gonna make this hard? How are they gonna torture us a little bit? Okay. So before we get any further, we're about to do a question here. Do we know the different types, concentric circles, the different types of numbers when they say whole numbers, natural numbers, real numbers? Do we know what those mean, or do we just kind of get scared and say,
I forgot.
Okay, so let's talk about those. And not because it's defined in here, but because they're going to be hitting you with, this is a whole number, this is a rational number, this is an integer. And let's make sure we know what's up, okay? So, the most simplest kind of number would be numbers that you can teach to a baby, would be numbers they can count on their fingers. What is that called? No, but you're very close. The natural numbers, yes. Natural. And natural is your finger numbers, the numbers you can count 1, 2, 3, 4, and that goes up to 1,000,000. It's not only 1 through 10, but it is no decimals, it is no negatives, it is no fractions. What is the first thing that we add to the natural numbers to make our brain a little bit smarter than a baby? No. Whole numbers comes next. Because if you remember, they didn't invent this number until 1,000 years ago. Well, maybe 3,000 years ago. I don't know, I'm making stuff up. But the number is 0. And then once we have all the positives and 0, then here comes the negatives. And what do we call the negatives? Integers. Integers. Spelling. And if we have all the positives and the zeros and the negatives. We're starting to fill in the cracks between the positives and between the negatives, all the numbers in between 1 and 2, and that's where we get to rational. And rational basically means that you can make a fraction out of it, like 1/2, or 1/3, or 8/7, or whatever it may be. And if we have to go bigger than rational, well, that would mean that we include the really funky numbers. Now, a lot of times, I guess that can just be another one here. We've got irrationals. 1 bonus point for every irrational number you can state. Pi. 1 bonus point. What else do we got? E. Numbers, not letters. Anything else?
Square root of 2.
Nice. Square root of 2. And there are many, many irrational numbers, but these are the ones that we work with very often. And then there's like, real number, but whatever, we're getting too big now, okay? So, it is very common for them to say that these numbers have to be natural, or they have to be integers. And so, make sure that you kind of know this difference. Again, the easiest way for me to think about it, because it is not instantly like integers, it includes the negatives. For me, I think, okay, well, the naturals are the finger numbers, then you add 0, then integers, and includes the negatives. I kind of do it like that. There are fancy, like, letters to represent these, because mathematicians, we just hate writing. You can see my handwriting, it's awful. So, for natural, it's an N. And these letters, they have like little double, they're like fancy, you know how like the R for all real numbers has that double? So it's the same thing. The natural numbers for N, it kind of looks like, it's just got like extra lines on it in a weird way. And the integers is Z, with some extra stuff on there, and then you want to know real. What is the letter for whole numbers? I don't even know. If it doesn't matter, we don't know. If I don't know it, I'll tell you, then we're good. Just in case you see a Z, it means the integers. Not sure how big I'd be on that. Okay, let's finally do a question. Sick of that, that's 4th grade. We know that A is less than or equal to B, is less than or equal to C. We know that these are all integers. And we are going to know that we have the mean is 4, the mode is 5, and the median is 5. What are A, B, and C? Well, we have to work back here, and honestly, it's not super straightforward. Any thoughts about where we should start? Obviously, the mean means the average needs to be 4. The mode means the most needs to be 5, and the median means the middle one needs to be 5. Any ideas on where you want to start? Median is great. The median is 5? Well, perfect. We got A, B, C. So there's 3 terms, so the middle one has to be 5. So perfect. B equals 5 for sure. Median is a great place to start. What is, basically you can think about it like this. Nice, they gave us the median and we used that information. Median's kind of handled. Do you want to go and talk about mean next, or do you want to go and talk about mode next? Which one seems like the simplest, the easiest to think about? Mode, right? Remember, mode is like the dumb brother here. Mode is just the one that's most popular. And it doesn't say that they're, there's no mode. It says the mode is 5, which means 5 is the most popular number. which means there's at least a repeat. So that means either we have A is 5, and B is 5, and C is 5. Maybe they're all 5s. Or maybe the first 2 are 5s, or maybe the last 2 are 5s. But certainly 2 of them are 5s. Could they all 3 be 5? No. And why not?
4.
Because now we need to be thinking about our mean. We've thought about median and incorporated that. We've thought about mode and we've started to incorporate that. But our mean is now the last thing in our head. Okay, we know it needs to be 2 of them. Is it gonna be 5, 5, and something else? Or is it gonna be something else, 5, 5? Case 1 or case 2? I saw case 2, and you're right. If we make it 5, 5, and a number that continues to be bigger than 5, how are we going to get the average to go down to 4? There's no way, right? If we are here, then our options are either 5, already too big. We already lose. So, he was correct. C is going to have to be 5. Because we need A, the smallest number, to have the possibility to lower our mean. And now lastly, what is A going to be so that we can make the average of these numbers 4? 2 is right. Now how did you do 2?
Because it has to be an even number because the mean is 4. And so 5 plus 5 would be 10.
Mhm.
So if you add 2, it makes it 12, divided by 3 is 4.
Awesome. With 3 numbers, was that all up in your head? Genius. If this was 10 numbers, probably hard to do all in your head, and you're still a genius, but maybe it would get a little bit more complicated. So, what if we use the mean formula, right? Because these things have formulas, and we just solved for it like a 6th grade question, okay? The mean is equal to, add them all up. Look, we'll go sigma for you guys, and then divide by how many there are, and the mean, which is 4, if we add them all up, I don't really know what that would be, but it would definitely be A plus 5 plus 5. And then how many are there total? 3. And this works as a nice little 6th grader question. Times 3 times 3, that makes 12, and then subtract 5, and then subtract 5, that makes 2 equals A. Oh, 2, nailed it. Okay, so you can kind of see how these are relatively simple concepts, and they've somehow managed to make it a little bit convoluted. Here's the strategy. You're gonna be able to use median, to use mode to make some decent progress. Eventually, you're gonna have to incorporate mean into that, and maybe you can reason it out in your head. Another option would be just to try numbers, plug and chug, but maybe we're on the quiz or a test and there's 7 numbers here, and that's just too many to do the plug and chug. And so then, use your formula. It's not all that bad. Add them up, divide by n is equal to the mean, and then solve for that last one. So, I think this is the last question we're gonna do, and then we have a little bit more notes, and then we're gonna get homework. So what if we know that integers A, B, C, D, mean, median, mode, and it is 5, 7, 6. Oh, I wrote those backwards on my paper. The mode is 7 and the median is 6. Okay. Part of this does take a little bit of intuition, a little bit of thinking, a little bit of guts. How do you want to start? probably the best place is with your median, right? And you want to kind of work a little bit with the median, a little bit with the mode, and think about those two things. Our mode is 7, which means we have the most 7s. That means we've either got 3 7s and one other thing, or all 7s, but all 7s can't be right, of course. We can't have 2 and 2, because then we would have multiple modes. So what is most likely is that we have 7, 7, and then 2 other numbers, x and y. Everybody follow me on that? Okay. Now, where do those 7s get placed? Are those 7s the 2 smallest numbers, the 2 middle numbers, or the 2 highest numbers? What do you think, Devin? I know, all right. And then you also started to say something, so sorry, I said Devin. What do you, or he's pointing to you now, so you get to go. The 2 highest is a very good thought. They certainly can't be the 2 lowest, because our mean is never going to be low enough there. They can't, why can't they be our 2 middle numbers? Because the median is 6. And if they were our 2 middle numbers, it's not going to work for us. So they are going to want to be C and D, our 2 highest numbers. We're still now looking for those 2 lowest numbers. Any idea where we can go next? Luke and Jack have been quiet today. You guys got any ideas? Alright, what if I give you a hint? Before we get to the mean, we need to figure out that median. Mean is always like the last thing. We should be able to figure out another number here pretty easy by considering the median. You got it? Is that a hand or is that a number? You're right. B is gonna be 5 because the median is 6. The number in between 5 and 7. And that gets us to this last number, and you can have a genius moment of calculating it in your head, or you can have a plug and chug moment of trying to just try numbers over and over again. We know that it's smaller than 5, and the surefire way to do it is to just do a formula that the average of 5 is equal to, add them all up. I don't know what A is, but I know that it's 5, 7, and 7. Divide that by 4. We can multiply to the other side to make 20. A plus 7 and 7 is 14 plus 5 is 19. Subtract, what is A gonna be? 1.
Wait, so what is the median? 5?
The median is said to be 6, and B has to be 5, so that what's between 5 and 7?
Oh, okay.
6, right.
Okay.
Because if we make this 4, well now the middle of 4 and 7 is only 5.5. It's not 6 anymore. So we chose 5 based on that. Okay. Back to notes. There are 3 more things. The first 3 we learned were called the measures of blank blank. Central tendency, okay? Now, central meaning middle. So the measures of central tendency are like the mean, the middle in terms of average, or median like the middle in terms of the literal middle, or central as in mode, the one that shows up the most if you put them in. So those all have to do with central tendency. So then we have measures of spread, which is 3 more things that are very similar, except for instead of figuring out how close together they are, it's kind of like you're figuring how far apart they are. So, anybody want to take a shot? You've heard of at least 2 of these. What are some statsy words, some statsy things, maybe when it comes to test scores or PSAT scores, or maybe when it comes, have you heard any other fancy words for stats? I'll give you this much.
Standard deviation.
Excellent. Standard deviation. standard deviation is one of our measures of spread. And standard deviation is actually a teenager's best argument. You guys and girls love standard deviation. I'm sure I used to do this all the time. I'd get the test back. Oh my God, a 72, are you kidding me? And then I'd go home and parents at home, guardian at home, grown up at home would say, 72. And I'd say, oh, yeah, but you know James got a 50, all right? Right? And the first thing you do is you say, yeah, 72 sounds awful when you think about it compared to 100, but think about my friends. I'm smarter than my friends, and that's what really matters, grown up. So that is just standard deviation, okay? Standard deviation is how far you are from the mean or the average, or we'll say mu because we like our new letter, mu. Again, it's no different than that argument of I might have got a 60, but mom, the average on the test was a 45. I'm a genius. I'm trying to tell you, right? Now, standard deviation is the one that really has the most difficulty to it out of all 6 of these, okay? Because up next is the range, which again is something that we've heard of before, and the range makes a lot of sense even in just a straight up English definition of the word range. The range is all the possible values of a function, and so the range of your set is the highest minus the lowest. So the range on a quiz might only be 10. What does that mean about the quiz? Everybody pretty much did the same score, right? Maybe it was a really easy quiz. Maybe everybody got a 10, or everybody got 100 or a 90, right? And it was just a 10-question quiz, and it was all very easy, and all the grades were hundreds and 90s. I did my SMART goal. You guys know SMART goals? So the teacher makes it hard so that you fail on purpose, and then you gotta take it again later, and then you get 100, and it's like, oh, the teacher's such a good teacher, right? So I did a SMART goal in trig, and the range was 27 because the scores were between 0 and 27. It was super hard on purpose. They failed it on purpose. It wasn't actually graded, but that was the range. I had to calculate that for my SMART goal and put it into the data. So my range was 27 for the class, right? Very easy to do. 27 minus 0, done. For our tests, I could take the highest test and the lowest test. The highest grade was 102, and the lowest was, just kidding, I don't know what the lowest grade is. And the last one, which is our favorite word of the day, interquartile. Well, some of us, it's still sigma, I understand that, but the other people might have the favorite word of the day being interquartile range. Now this one is probably the least take it at face value. What does this actually mean? We can use etymology, break down words. We know that range means highest minus lowest, okay? I'm kind of getting that, okay? What pieces of interquartile can we break down into smaller pieces that we understand? The first part, inter, means in between, of course. And quart, and then isle is just like, an ending that means nothing. What does quart mean? 4. So, here's what we're talking about for interquartile range. Again, kind of just some crazy sounding thing. We're gonna take all of our data, and how many pieces are we gonna cut it into? 4. So that means we're gonna start by cutting it in half, then we're going to cut those halves in half again. Okay, now let's think just where this is the very last thing I have written on here. Let's think for a second about all the way back when I talked to you about mean, median, and mode, okay? If this is all of our data, what is right here in the middle of that data? The median. And I told you there's a little bit of another word for median. It was Q2. Again, that's not a very good word for median, but it comes up here in interquartile range. We call that Q2, which kind of makes a little bit of sense. If you're in a class with 4 quarters, today is the last day of Q2, and we're halfway through the class, right? So that makes a little bit of sense, which means that what would you call this? Q1, and what would you call this? Q3. Now here's where it's a little bit unintuitive. Q4, nobody really cares about Q4, because where would Q4 be? Q4 would just be here, and it's not really interesting for me to ask you what is Q4, because it's just the biggest number. So like, there's no math there, it's boring. So to be honest, some students just struggle with interquartile range because they're like, it's quarters, but there's only 3. You're gonna be okay, right? It's quarters, but there's only 3. Q2 is the middle one. Q1 is that 25% mark. Q3 is that 75% mark. And that honestly should make enough sense that you don't panic about the Q4. Now, because of this, interquartile range has we're gonna talk about bar graphs and pie charts eventually, but interquartile range loves and basically creates a very specific type of chart. Do you know what it's called? She's nailed it, a moment of genius, a box and whiskers plot. Now, a box and whisker plot is basically this thing that I just drew for you, okay? Except for, it looks a little bit different because we need whiskers like a cat. And so a box and whisker chart looks like this. These middle 2 is where we get Q1, Q2, Q3. And then out here is where you have your min, and out here is where you have your max. Again, the max is Q4, but who cares? That's boring. Nobody cares about Q4. And this is called box and whisker. Now, box and whisker, when you learn about pie charts and you learn about histograms and bar graphs, you think box and whisker is the worst. God, I hate that thing. But actually, box and whisker is kind of nice, okay? It tells you right where the median is, right where the middle. It kind of breaks it up into thirds. If you were taking a test, you would definitely not want to be in this region, right? These are the kids who scored poorly and weren't even in that middle bit, right? The middle 50% is in that middle box. Now, sometimes, again, you might not even need to draw this because it's a little bit obvious, but your box and whisker chart, which looks like this, likely is not gonna be symmetrical like this, okay? If I do this, it stays symmetrical the whole time. So what is most likely is that your box and whisker chart should be something like, okay, here's the middle 50, but the median is a little bit closer to 75 than it is to 25, and the max is only right here, and the min, this could be a totally legit box and whisker chart, okay? That means that 25% of the people are in this section, 25% of the people are here, 25% of the people are here, and 25% of the people are here. A lot of times when I give a test in trig, this is how it looks, right? There's like a quarter of the class that get 100, then there's like a quarter of the class that get a 90, then there's like a quarter of the class that gets 75s, 85s, and there's like a quarter of the class that gets 50s and 60s, right? So a box of whisker chart does not have to be symmetrical. All right, well, we are basically done for the day. I want to talk with you just for a second about one last thing, which is standard deviation. Okay? Standard deviation, like I said, is the most complicated of the 6. It has a name because nobody wants to write standard, and if you try to shorten it, it looks like STD, and we can't have that. So standard we need a little symbol for it, and that's going to be this thing. It is not a theta from trig. It is like it's almost like a baseball hat on a stick figure. It might look like that. It's just a little circle with a line that is kind of attached to the top of it and hangs out like that. That is standard deviation. We'll talk about where we can find that in the calculator if we have enough time. Standard deviation has a formula. Now the thing about this formula is that nobody likes to do it. Standard deviation just has the worst formula ever, and standard deviation is basically a calculator only stat because humans just hate doing standard deviation. It is the square root of a fraction with an n on the bottom, which is like, okay, we've seen fractions with n on the bottom, but we have sigma x minus mu squared. Ugh. It's an awful formula, okay? The reason it's here at the very end is because it is on the homework, on one question, and it's an annoying formula to do. Now, we will do this formula less than 5 times in this whole year. So 99% of the time we talk about standard deviation, it's going into the calculator and we're doing it. But tonight, what this is to sum, that's what this means. This is your term that you're talking about minus the average, okay? Term minus the average is how far away from the middle you are. Remember we talked about how, oh mom, but I beat that kid by 12 points, right? So you need to talk about how you are compared to the average. And then this squared here, that squared is gonna make sure that whatever number we get turns into a positive number because we don't want a negative when we're doing this. And so that squared is gonna take, even if we get a negative, it's gonna make it positive. We're gonna have to sum all those up and then divide by n. Now, this is probably the most important thing because I imagine the homework will be pretty easy except for this one part, which is gonna be a little bit. Okay, so let's calculate by hand. 14, 14, 16, and 20, and let's calculate the standard deviation. In order to do our formula up here, we're gonna need to do the sum, that's not really a variable, of our term, that's not really a variable, minus the average. So in order to do this formula, we need the average. How do we find the average? Add everything up, divide it by the number of terms. So 14 plus 14 is 28, plus 16 is 38, 44, plus 20 is 64, divided by 4 and you get 16. Divided by 2 to get 32, divided by 2 again, you get 16. Our average is 16. Do it in the calculator, you get the same thing, no big deal. We also need the n, the number of terms, which we know is 4. So now let's do our formula. Okay? Our formula is we need to take all of our scores, compare them to the average, square it, and then sum them up. Again, gross formula, but let's do it. How far away is 14 from the average? I started on this side with 14. 14 is only 2 away, so I'm gonna start with 2. How far away is 14 from the average? How far away is 16 from the average? 0. How far away is 20 from the average? 4. Okay? Now, we need to square all of those numbers. What is 2 squared? What is 2 squared? What is 0 squared? What is 4 squared? 16. Now, sigma. Add them up. 4 plus 4 plus 16 is 42. 24. 24. This formula, ew, but we can do it. What is 24 divided by 4? 6. And so the standard deviation is the square root of 6. All right. Do we have calculators? Is there anybody who does not have a calculator at all? We've all got one? You don't have one? Do you not own one and need to rent one from IB? Okay. I will show you the picture one. I will try to figure it out tomorrow on my teacher work day. You can use this one for now. Okay. With our waiting moments in class, I'm gonna show you how to use the calculator so that you never have to do this again. Because honestly, I don't ever want to have to do that again. So, calc. Where is the button where we can talk about stats? It's got a fancy name. Stat. Yup, right in the frickin' middle of the whole calculator is the stat button. What we need to do is make sure that the calculator knows our data set, and so we're gonna make sure that we edit our stats. So when you press the stat button, the very first option is edit. Are you there? We're gonna press enter. And then we're gonna have L1, L2, L3. You got it, Luna?
Yeah.
Perfect. In there, we're gonna make sure we get our stats, which are 14, 14, 16, 20. So we're gonna type 14, enter, 14, enter, 16, enter, 20, enter. And that's our stats. And to list 1, they should be going down. Okay? Now, the calculator knows our stats. So now we need to use those stats to calculate whatever it is we want. So we're gonna press the stat button again. We don't need to be in the edit tab. The calculator tab. Press the enter button on the very first one that says 1 variable statistics. Press enter a whole bunch of times. And if you've done that, the calculator will calculate your average and your standard deviation. And it will look just like this. 2.449. Don't back up too quick. You got a piece of paper and everything with you? Alright, we will get our